Hi, hello my dear friends, welcome back to the channel. This is the fifth part of LO Leakage. In the previous video, I was talking about the strategies used in the uplink signal generation in case of 4G OFDM systems. The main concept which we had spoken was related to half subcarrier shift, right? So in the transmitter part, we would have done the half subcarrier shift. So in the receiver part, which is done in case of a base station in the uplink in the uplink direction, the half subcarrier should be shifted back, right? So let's say without before doing all these operations, if I take this xp of n, and if I take the spectrum frequency spectrum of it, then it would look like this, and you will see that the unwanted dc is present at f is equal to 0, and our information is shifted, right? So now I will not do DC removal, but cycle prefix is required for sure. So after that, if I do the half subcarrier shift, let's say I will get this signal, and if I take the Fourier transform of that, then I will see that this is the spectrum that I am gonna get. But if you see at half, there is a DC component, right? There is unwanted DC component, but the thing is, whatever information we want, that is present at the right locations. But if you try to remove the DC, okay, even if we employ this DC block, then we will see that in this particular spectrum, the DC will disappear. Okay, so there is no DC here. So now we will see, what equations or what algorithm should be written in order to remove the DC. And coming to the DC removal part, DC removal, DC corresponds to the average value of the signal. So you take the average value of the signal corresponding to all the samples, which is giving input to this DC block, and to calculate the DC in the beginning. Then for all the samples, you subtract the DC in this way. Okay, so to each sample the DC is subtracted, and you will get the DC removed signal. Now how many samples to be used, that is a question mark. So right now, since we are considered 4G OFDM system, the bandwidth is 20 megahertz, subcarrier spacing is 15 kilohertz, and the endpoint FFT is 2048. This is as per the standard, okay, 3GPP standard. So in the ADC part, we're gonna do the sampling, right? The sampling equation considered is n times delta f. That's how we get 30.72 megasamples per second. So, but I will consider the samples worth of only one particular symbol, that is 2048 plus 160. That would give you 2208 samples. So now I can do the average for 220 samples. Okay, one way. So if I do that, then the my DC estimate would be better, and then I can remove the CP, and then I can go for off subcarrier shift. But we can even swap these two blocks. So let's say CP removal is done fast. In that case, rather than this, I will be going to do the averaging for only 2048 samples. Since averaging is done for only less number of samples, maybe the DC component might not be that much great. Um, but definitely we need to simulate it and see in the MATLAB, which would be better. So there is one more option, like at this point I'd right now consider only one symbol, right? Like what if I consider 14 symbols? So then my samples would be 30720 samples. So I can consider all these samples, right? All these samples, and do the DC average, because for these number of samples my DC estimate is going to be very good. Then after I can perform the further operations. This is another way. But anyways, to fine tune this the algorithm, I would recommend that you can simulate it in the MATLAB. So what is the incoming signal? You can take the signal to be QPSK 16 com, and you add the noise, and um, you add the LO leakage as well. You know what signal to add here, and for that you can take the parameter A as a the variable parameter, where you can fine tune the LO leakage, the amount of LO leakage, and then you can perform all these operations in the MATLAB, and then you can see the output. So the what output you can see, the one thing is the constellation, right? You can see the constellation, and observe how is your output, whether the DC has been removed completely, or the DC effects are very some DC residual is present, things like that. Okay, so by that way you can fine tune the algorithm and use the appropriate more robust algorithm. um, I hope the things are clear here. So I will move on to the half subcarrier shift. So I was mentioning that to the DC removed signal, we need to apply this particular exponential component. Here I just mentioned off, and I was telling off corresponds to off subcarrier. But let us see how this off corresponds to off subcarrier. This is in the discrete domain, right? Just to take the time domain. So this was a time domain signal. So before doing this ADC, to this ADC, to this time domain signal, this is pretty much straightforward from the Fourier transform property, right? That we can do this exponents, which is 2 pi. I need to mention frequency. Frequency is half subcarrier, I mentioned, and then t. Okay, but when we do this ADC, then our sampling, as per the basics of sampling, like t should be replaced with the NTS. So that's what I will replace in this equation. Then what will happen? So this will become NTS, right? So ADC is sampling rate. What is that we are using? This is the equation which we are using as per the 4G, right? So TS will become, so instead of this TS, the component which I need to use is 1 by n into delta f. So delta f gets cancelled. So what is remaining is just off here, and that n is there, and then n. So this is exactly same as this one. So that's why this off the discrete domain corresponds to half subcarrier shift. I think the equations for both DC removal and the half subcarrier shifts are very clear. In the upcoming video, let me talk about what strategies are employed to remove the LO leakage in case of 5G. Whether any strategies applied or not, we will see. Till then, stay tuned. Have a great day. Bye bye. Take care. Please do subscribe.